Here we see two different ions. These are both ions. They both have charges. On the left, we see a sodium ion. The sodium ion has a positive charge. So this was one atom of sodium, and it lost an electron, so it became positively charged. On the right side, we see a more complex molecule. Okay, and molecules can also gain or lose electrons to become ions, to become charged particles. In this case, we have a negative charge. We have one extra electron in this whole molecule, and so this becomes a negatively charged ion. This is what we would call a polyatomic ion or a molecular ion. Polyatomic means many or more than one atom. And this is so when we see this kind of a structure, every place where we see a corner, like here, there are one or more atoms, usually more. So two or three atoms. Every corner where there's nothing written represents a carbon atom, and then the carbon atom will usually have some hydrogen atoms attached to it. So if we were to draw out this entire molecule, it would have a whole bunch of lines and carbons and hydrogen sticking off of it. So this is a shorthand way to draw a molecular structure, but the fact that there is this one negative charge means that the molecule itself is an ion. So the question is, as an atom or molecule becomes charged, how do its electrons, protons, and or neutrons vary? Well, the protons and neutrons are in the nucleus. They're usually unchanged. It would take a nuclear reaction or nuclear decay to change the nucleus. And some substances decay, their nuclei decay naturally, but those are what we think of, or those are radioactive substances. And they will have their protons and neutrons. They'll have the numbers of particles in their nuclei change. But most of the substances we're familiar with, the nuclei stay the same. The protons and neutrons, the number of protons and neutrons stay the same. When a chemical reaction happens, it's because of interactions between electrons. So an atom or a molecule will become charged as it gains or loses one or more electrons. Charge when an ion is formed, when a charge is transferred, it's because of moving electrons or moving ions. You're not adding or removing protons. Whoops. There we go. Okay. Now, water molecules, I've mentioned they're polar. They're polar. What does that mean? That means that we have a positive side. The hydrogen side of the water is positively charged. The oxygen side is negatively charged. So water molecules will align themselves so that the negative sides will be attracted to the positive side of the next water molecule. And here we have the negative side attracted to the positive side. And they are a little bit sideways because there are so many of these water molecules. So the water molecules actually stick together, and that's a phenomenon called cohesion. Polar water molecules attract one another. If you've ever done a belly flop in a swimming pool, or if you've ever gone water skiing and fallen and bounced off the water, you've experienced how water molecules will stick together, and it takes some force to break them apart. Though the space between molecules in this visual is exaggerated, in other words, the molecules should be much more packed together, the dashed lines suggest the force between each pair of molecules. So that these lines between the molecules represent forces, attractive forces, electrostatic forces, which we've learned about. The forces change continually as the molecules move. This is water. Molecules don't stay in place. They move, they rotate, and the hotter it gets, the more they move, the more they spin, and the more they rotate. So there's a question that says develop two hypotheses about what would happen if the atomic or molecular ions you saw earlier in the last slide were added to the water molecules as shown. Consider the merits and drawbacks of each hypothesis. Select the hypothesis you think is best or combine them, then refine your stated hypothesis. Refine your final hypothesis. So one hypothesis could be that you get an ionic bond. If you drop an ion into let's drop a sodium ion in there. Okay, so we have a sodium ion. So one hypothesis is that a bond could form, an ionic bond could form between the sodium and an oxygen atom. This is not too likely because the oxygen atom is already bonded to the hydrogen. And it takes a good bit of energy to break oxygen and hydrogen atoms apart. So just dropping ions in there is not likely to do it. Another hypothesis is that the ions are attracted to the water molecules without actually forming a chemical bond. So you'll get a positive ion here and maybe a negative ion here. So this is probably sodium and then this is chlorine. The pen I've selected is a little too fat to draw these, but then you get what kind of atom would this be, or what kind of an ion would this be? This would be sodium because it's attracted to the negative side of that water molecule. So these ions are attracted to the water molecules without actually forming a bond with them. And this is more likely because the polar water molecules would attract the ions. So can you think of any other possibilities that might happen if you put atomic or molecular ions, mix them into water?